we need our distance, so same thing, right? Our time on that flight, our fuel burn, and we need, I mean, endurance and all this stuff kind of ties in, right? Like, we don't really need to like add it as this big thing, but we'll get there. What I'm trying to get at though is what gives us this? What speed actually has time associated? The example I've been giving is like, you're driving 80 miles per hour in your car and you never stop. You have auto drive on, you got a Tesla, and you're just doing your thing. If you drive for an hour, you go 80 miles, right? So in an airplane, we have indicated, we have calibrated, we have true, and we have ground speed. Which one of those is going to give us time? I like to say ground speed is the time measurement because it's our speed over the ground. It's our miles per hour, if you would. So therefore, simply put, ground speed equals all of this, okay? That's how we're gonna do this. I'm working backwards. So how do we get ground speed, right? Very simple. True airspeed plus our wind correction, right? Okay, so now we go down the list. So we have true airspeed plus wind correction angle. Great. Okay, how do we get true airspeed? Well, it's calibrated airspeed plus, I think, temperature and then pressure altitude. So we could say non-standard temperature or non-standard pressure, however you want to remember this. But like either you use a CX3 or however you want to do it. I use a CX3 to make the math easy on myself, and I'm not a student pilot, so I don't have to like show all my work the same way. But what I know is I just do temp plus pressure. So we could say pressure altitude, for instance. I think that's how I input it in the CX3. So I got PA, I got temp, and I have CAS. Well, how do we get CAS? Well, we need our indicated airspeed plus the POH. Cool? So everybody here is probably a sling pilot. Can you open this for me?
Yeah.
In the sling POH, which is very limited information-wise in my opinion, we just have some subtle information. But this is important, like on a check ride, if someone asked you this for whatever reason, you'd say, well, indicated and calibrated are the same. And they're gonna go, why? And you have to prove it. So you go, well, according to the POH, it's section 5-6 in the sling handbook, page 90 on the PDF. The point is, I don't know how well this is recorded. I'm not very professional, guys. I'm not.
Past 45, right?
Right. So the whole point is, our speeds are different until 45 knots. What is our rotate speed? What is our climb speed? What is our cruise climb speed? And what's our cruise speed? They're all above 45 knots. So we know, generally, indicated and calibrated are the same speed. But you still have to prove it legally, because the POH is our legal document that says we can do this thing. So we need to prove it. So you go, well, above 45 knots, they're the same speed, so indicated and calibrated are the same, and I can show you that via the POH, section 5-6. These like 5 performance pages are gonna become your best friend while you do this. Get used to it. And so the main point I wanna express here is most people, I didn't know until very recently, probably 2 months ago, the difference between calibrated and indicated. I could tell you calibrated airspeed is indicated airspeed corrected for installation error. What does that mean? Really simply put, super quickly, if you have 2 parcels of air, and here's our wing, and there's a pitot tube on this wing, right? Ram air is going into our pitot tube for our airspeed, right? Well, if you're at 30,000 here and you're at sea level here, there's more air at sea level than there is at 30,000 feet. That's like pressure, right? Density air, all of that. The point is, what the POH is stating is that unless you're at 45 knots, before then, the indicated airspeed will read different from our actual, our calibrated airspeed, because any slight deviation of that pitot tube means air might be hitting it a little funky until you go 45 knots, where then they'll read the same because enough air is ramming in that tube. There's gonna be a lot of tangents, so sorry. Point is, let's do some quick math, right? I'm just explaining for now. So first things first, we have our POH, so we know what our pass is, so we have the first two items we need. We know if we're taking off, we're gonna be doing 72 in our climb. In our cruise climb, we're gonna be doing 75 to 90, and this is the checklist, right? We have to follow this is sling. And then when we cruise, typically we'll be like 90 to 100 indicated airspeed, right? And then so like take off, cruise, climb, and then cruise, and then our descent, typically we're gonna do about 90 knots, right? We'll say descent. So right, takeoff, cruise climb, cruise, 90 knots. And remember, this is indicated, right? This is indicated airspeed. So this is not our true, this is not our ground speed, this is just what we're reading. And it's okay because we know indicated is the same as calibrated because of the POH, so that's fine. While we're doing this, our speeds now are covered. We don't have to think about that anymore for when we put our indicated or calibrated for the different altitudes we're gonna use. So I'm gonna erase this. So what's our temperature? So we need temperature and we need our altitude and we need our field elevations for where we're going and what we're doing. So for this example, I unfortunately don't have a flight plan prepped, but he does. He's going to be going from Long Beach to Palomar, and it looks like, are you cruising at 6.5? Or what are you doing?
5.5.
5.5. So over here on the side, what we're gonna say is we're gonna have LGB, which is Long Beach, and we're gonna have, what is it, KCRQ, Palomar?
Yes.
KCRQ, Palomar. So our Long Beach field elevation is 60.
It's in here if you need to use that.
Awesome. So I know I'm kind of jumping around, but we're just gonna start getting there, and then I'll explain as we go. But primarily, I'm just starting with what information you're gonna want, and there's gonna be a lot of numbers, so this is gonna get annoying quickly, and I'm not the best at this. So our field elevation, right? Because it's our indicated altitude for takeoff and descent. So this way we can get our pressure altitude, we can kind of understand the picture. So if Long Beach is 60 and I do FE for field elevation, that's how I remember it. KCRQ.
331, I think.
Okay, so we're gonna say it's 331. I'm not double checking any of this. It doesn't matter for me right now because I'm just trying to show the math and how I do the math. So our field elevations. Now, coming back here, we need our temperature, our pressure altitude, and we need our wind correction angle. So what is that gonna be? We're gonna need the temp, we're gonna need the winds, and we're gonna need the pressure, the baro, right? Because these are how we're gonna find out all of this data in our CX3 or whatever you wanna use. But for me, these are my building blocks. So here at Long Beach currently, right, I'm gonna use the METAR because I'm gonna say I'm gonna be doing this flight right now. So our METAR is also, practice reading METARs, good skill. So winds are 210 at 6, 210 at 6. Our temperature is 23, and our dew point is 13. And our pressure, 16, my mistake, I apologize. 16, and our pressure is 29905. So write this down with me or watch me execute it, however you want to do this. Great, so now we have our field elevation and our non-standard temperature, which is going to give us our pressure altitude. Or we'll get there, I'm messing myself up. So we have our building blocks. This is all I'm trying to get at. And I'm gonna get the Palomar information, but we'll come back to Palomar. We're just gonna do our initial beginning here. So Palomar is 280 at 6. So 280 at 6. Our temperature is 22 and 16. And our pressure is 29904. So to me, it seems like a pretty stable day down here on the coast. It's blue skies, pressure gradient isn't that big for about, it's like 60 or 80 miles or something. It's pretty good, it's a good day to fly. But we wanna know what our performance is gonna be like. So this is where now we will come to our CX3 to get the pertinent information to start figuring out what we wanna know, right? Because our ultimate goal is our distance, our time, our fuel burn, And in that information, we're now going to get our top of climb, our top of descents, our rate of climb, our foot per minutes, all of this shit, right? Because ground speed, again, is our time measurement. So anything that's foot per minute, foot per nautical mile, anything that's distance or time, we're gonna get because we need that ground speed. So if we go to the beginning of our CX3 here and we look, first things first, right? We want altitude because we're trying to get our pressure altitude. So for Long Beach, we're gonna start here first. So I'm at 60 feet field elevation, that's our indicated altitude. So we're gonna say 60 feet indicated. Our baro is gonna be 2.9er, boom. We now have pressure altitude. So we have our indicated corrected for pressure, gives us 33 feet PA. So 33 feet PA, and we can do our little feet. Now, when I add my non-standard temperature, my pressure altitude corrected for non-standard temperature, now we get our density altitude. So it's 974 feet DA at takeoff. Wonderful, right? Because we're gonna assume the airport's like the same environment. So we now have our our density and our pressure altitude for Long Beach. So now, when we come up here, we look again. So we have our indicated airspeed. We know we're gonna be doing 72 knots indicated on takeoff, right? So we know we'll be doing 72 calibrated, but now we want our true. So we go to the airspeed tab. Very simple, right? And I'm probably making this sound so simple because the CX3 does all of it for you. You just need to know what you want and how to use it. So if you notice when we look, we have true airspeed at the top, so we can assume that's what we're getting from this. So our outside air temperature is 23. And if you're really good and you look at your METAR and it has a T group, we can do our true air temperature, which we do at Long Beach. It's 22.8 Celsius is our true air temp. So we'll say 22.8, wonderful. And we said we're gonna be doing 72 knots on takeoff for our climb. So we're gonna say 72, boom.
For calibrated.
For calibrated, yes. And our pressure altitude we know is 33 feet, so I input it. So now we can have a pretty good estimate that we're gonna be doing 73 knots true on takeoff. Wonderful. So I'm gonna erase some of this again, because hopefully you can pause and write it. I don't know. It's my first time, I'm sorry. So I'm gonna just get rid of this info for now. But we're gonna say KLGB, sorry, B, take off 73 TAS for our true airspeed. So now, how do we get ground speed? Well, let's go to ground speed. Ground speed doesn't give us our ground speed, it's asking for it. Bummer. Well, what did we say up here? We need our wing correction angle to get our ground speed, plus our true airspeed. So now, we can come down here, we go to wing correction, and on wing correction again, there it is. Ground speed is our top thing, that's what we're looking for. And we already have our true airspeed populated. Oh no, but now we need true course, true heading, we need wind speed, wind direction. That's easy, but our course and heading, that's where it's gonna be a little confusing. So this is where now we need to go back to our flight plan before we continue.
So I have it written out here.
For brevity, we already have it, but
Yeah.
if you were to look at a flight plan you were to make, I don't know how great this is, I'm sorry if this is like so fucked and you're like,
You can bring it closer.
So, if we look, you can see there's a rough estimate here. He has already done this, I'm not checking his work. What
It's
I want
for
to...
points slightly off the coast from those,
Well,
but whatever.
What I'm specifically wanting you to find is to understand the difference between true heading and true course. Is one magnetic? Is one true? What's the difference? When are they different? Because this will be important. And, I mean, again, as an instrument student, I didn't even know this until like a month ago, until I was grilled on it. So, the thing is, we have a lot of course changes very quickly at Long Beach because we're going to be doing a takeoff, runway heading, then we're going to do a left at the river, and then we're immediately from there going to continue on our flight plan. So you can kind of fudge the numbers a little here and like do your middle plan. Like, are you going to be at 5,500 feet in 4 minutes? No, not in a sling. So what's most likely going to be the most affecting? You could crunch these numbers all day long, or you could just simplify and make it easy on yourself. Maybe practice doing all of it just so you get the hang of it. All I'm trying to express here, though, is I'm probably going to do the left at the river, the like 200-170 heading area, because that's going to be generally along my next route. And I'm not going to be at top of climb till after that, most likely, anyway. So, now that I've kind of explained that, sorry, there's going to be a lot of difficult stuff from me here. We are going to use the 178. And now again, is that true or is that magnetic? Which one do we put in? Because right, magnetic would be heading, true is course. Cool. How do we know? Well, when you read it on ForeFlight, is it true or magnetic? I need to double check here because I'm not even so confident anymore because I always question myself. But I'm pretty certain when we read it on here, it's our magnetic.
You can change a setting to true. So when you do the plotter on ForeFlight, it'll read true.
Okay.
So just go in your settings and change
Under the
that.
units,
It's under
right?
units
Yeah.
at the bottom.
Okay, well, these two good gentlemen have just informed me. We can change it.
It's already changed, so on here when we do the plotter, it'll
It's-
read true.
It's true. So mine's magnetic. Good point of notion. In the sling, when we're flying with our compass, it's always going to be true because our magnetic heading is always corrected via the GMU11, our magnetometer. So regardless of what you're flying for instrument, it's always true basically. So you work backwards with instrument. For private, obviously you have to do correction and all that, which you don't because we have a magnetometer, right? You guys don't. So anyway, our wind speed we said was at Long Beach.
At Long Beach, 210 at 6.
210. So just real quick from that, right? This is all the same work we'd be doing on our VFR navlog, just kind of spread out. So we've got our winds, and then we got our true course, true heading math, right? Our wind correction angle, our plus minus, our magnetic deviation stuff, which isn't even covered on here, makes it even easier. But it's the same info, it's just giving an idea as to why we're doing this info. Because for me, it was extremely discouraging trying to understand why I need to do this like really weird back and forth on the paper navlog, where this makes it a lot simpler to me. So we know we're going to be doing 67.88 knots ground speed according to this on takeoff. Wonderful. So takeoff, we're going to say 67.88. I'll just round up. I'll call it 68 GS for our speed. Cool. Okay. Now, where are we going? Why is this information pertinent? We're going to climb to, right? So we're going up to 5,500. So now we can do the same thing to find out the information up there. Before I get too far ahead of myself though, what I want to show is what we can do with this information to find out what's going to happen at the start, right? So we can go back to our POH, and if we look at our POH, we now have, if we go back to our POH, we now have our fuel burn, we have our true airspeed, which again, even though I did the math on there, they're gonna want you to verify on here, which I will cover in just a sec once we go up to 5,500. But here we have our climb rates. Okay, so we're saying our density altitude is somewhere between 0 and 3,000. It's 900 something, right? We can assume we're gonna do, legally speaking, via the POH, we will be doing 800 feet per minute. Now me personally, I don't trust like that. So, how do we find this out more accurately? Well,
I think I have it pulled up on Google Chrome already.
okay. If we go to the interactive Koch chart, KOCH chart, we have two tables. Important thing to explain, if you ever use this is based off the most generic plane, airplane single engine land. It's just exceptionally average at sea level. So, well, technically at whatever pressure you give it, but for us, we always take this value from our sea level performance, which is 800 feet per minute. So, what is nice about this? We can go to our pressure altitude, and we said it's 33. Make sure you get rid of that 0. And then our temperature is 23. And so now if I tap or I hit enter, I now get, oopsie, 33, great. We now have 11% increase to our takeoff and landing distance, which is also in our POH, which we can pull up and do a quick percentage calculation of that. And we also have an 8% decrease in rate of climb. Great. So what does that mean for us? We take that from 800, so we can do our 800 times 0.08, right? So 8% of 800, 64, minus 800. We're gonna do 736 feet per minute on the conservative side, and we're gonna do 800 feet per minute on the legal side. So now you can interpolate between those two numbers, add 800 and 736, divide it by 2, and that's gonna be your climb rate. I'm personally gonna say, we're gonna do 736. Why not shoot low and then outperform your numbers? That'd be better, right? You always wanna plan for it to be bad or go further or have less fuel, right? Like if you fill your tank with 25 gallons, do you say I have 25 gallons in the computer, or do you say I have 20? So that, oh, I'm almost out of gas, but you always have that reserve now. Whatever, ADM, airplanes, do your thing. All I'm trying to say is at takeoff, we're gonna be doing 736 feet per minute. Okay, we have now got feet per minute on takeoff, quote unquote. Great. So now we'll do our 5,500 math. So where can we get the numbers for that? Well, we can do our winds chart from Long Beach. Is Long Beach close enough to where we're gonna hit top of climb? Probably. We can use our briefing for our flight plan where we get our winds aloft chart, whatever. I like to just use the airport wind and temperature chart because it just gives me like a general idea, and we're gonna be close enough that there's more airports along the way. I'm just gonna show you the quick math, and then you can always expand on this and go way deeper if you want. So we're gonna go to weather on ForeFlight. So I'm at Long Beach Airport, I hit weather. Now I hit winds, and what I'm looking for is 5,500. Well, darn, we don't have 5,500. We have 3,000, we have 6,000, and we have 9,000. So again, why don't we be conservative? I could say standard temperature lap, is 2 degrees per 1,000 feet, but I'm not sure today's a perfect day. So I'm just gonna go with the 6,000 value, which is written, which I can trust adequately, and say it's gonna be worse, right? It'll presumably be a little hotter or maybe a little colder, who knows? So I'm gonna say 18 degrees Celsius at 5,500 feet, because that's the value I'm getting right now. I will show you, just so we're on the same page. So I've got 18C, it's 15 degrees above standard atmosphere, and the winds are 180 at 5. So that'll do for me, okay? So we're gonna say it's 18 degrees, and it's 180 at 5. Yeah, 180 at 5, this pen sucks. So now we're gonna do the same exact thing we just did one more time. Great. So we're going to go to altitude. We're gonna say we're indicating 5,500, right? Because that's what we're gonna read. We're still within 100 nautical miles of our airport, so we can use the same temperature or pressure, 299.5, right? Okay. And we're just putting this in. Our pressure altitude is gonna be 5473 up here. So we'll say PA 5473. This is probably impossible to read on there. And our temperature we said is 18C. So our density altitude is now 7,067 feet. This is important because in the sling, when we are flying, does the engine perform on indicated or density altitude, right? Density. So the whole point is, are we climbing to 5,500 or are we climbing to 7,000 feet in this case? We're climbing to 7,000. So now the performance I'm expecting, I already can guarantee is going to be doubly bad, if not more, right? Because the sling is not a linear aircraft. It doesn't go 800, 600, 500, 300 up to 12,000 feet to service ceiling. It's kind of 800, 500, or 600, 500, 400 to 9,000. I don't know if you've ever flown to 9 or 11,000 feet, but it's not that good. It does not perform like that. Just saying. So, we now have our DA down here is 70, 67. So we know where we're starting and what our speed, ground speed, and our performance will be like, and we know where we're going and what our altitude there will be like. So we're gonna do all this math one more time up there to get our ground speed, our true airspeed, so we can understand what's gonna happen up there. So we just did that. Now, right, airspeed. So our outside air temp is 18. Our true air temp, we're just gonna go with 18. And our calibrated airspeed, we're assuming we're still climbing, right? Because we're at top of climb, right? We haven't stopped. But we're above 1500 AGL. So are we doing 72? Are we doing 75? Are we doing 90? It's up to you. I like to say 75 because I'm trying to, climb as fast as possible, right? You could say 80, but you have the freedom between 75 and 90. It is now your doing. So I'm gonna say 75. And our pressure altitude we know is 5473, we got that. So now we can say we're going to be doing 80, I need a new pen. I'll be right back. I hope this is followable. I'm just realizing now this is probably just incoherent, like the meme of the guy at the stadium explaining to the blonde chick in her ear. Anybody know? So we're gonna be doing 83 true TAS at 55. And so now once more, what do we need to do? We go all the way back down to our wind correction, right? So we went indicated, we know our calibrated, we corrected it, we got our true. Now our true plus wind correction is gonna give us our ground speed, okay? So if you're not understanding, just keep doing it with me, just hang on. So again, referencing the true course and true heading I already have from my friend here. I know that, and we know our wind speed. We got it, it's 180 at 5 at 6,000. I'm just gonna assume this is pre-flight planning, right? We're just good estimate. We're going to say we are on 120, because we're kind of on a long straightaway now. We're going straight down the coast pretty much. So 120 on the true course will do for us. Our wind speed, we said, is 5 at 180 input. Now we have 80.74 knots ground speed. I'll call it 81, I'll round up, why not? So we'll say 81 ground speed. Now you know exactly what's coming next. What does the POH say? Because we have to say it legally. The POH says between 3,000 and 6,000, we're gonna do somewhere between 600 and 500. We're closer to 6,000, right? 55. So you could say we're gonna do 550-ish. I would just round down and say 500, and you just, to prove, say yep, we can do this. Again though, is that accurate? No. Could you get more accurate and interpolate, scary word, and find the difference between these two is 3,000, the difference between these two is 100, 3,000 divided by 100. I'm not gonna get into it. It's too complicated and it's not gonna help you. It confused me for a long time. So what I just wanna know is this. The POH says we'll do about 500 feet per minute on the conservative side. Again, I wanna know what the Koch chart says, because as we've discussed previously, the Koch chart is our conservative estimate. It's our less likely estimate, but it's going to give us a base value that we can kind of trust because it's our worst performance, right? It's the most general plane. So what do we need? We need our pressure altitude. We say 5473. Great. What's our temperature? We said it's 18. Great. So we're gonna add 110% to takeoff landing distance. That doesn't really matter for us at this moment. But what it does is we're gonna decrease our rate of climb by 60%. Great. So quick maths.
And that's 60% from the POH value at sea level,
right? At sea level. So every time you hear Koch, think that value from 800 feet per minute, because that's our base value. So that's where I'm just doing this easy math from. It's 60% of 800. So you can do it, 800 times, blah, blah, blah. Some people have different ways. I'm a simple man. I just do 800 times 0.6, right? 60% equals 480. Subtract 800 from that, you're gonna get a negative number. It doesn't matter because the number is still the same. We're gonna do 320 feet per minute. So, according to this, the conservative value here, so 320 FPM, oh my God. I don't know if you can see that. The point I'm trying to make is we just looked at the POH. The POH says we're gonna do about 500 feet per minute, give or take. The Coke says we're gonna do 320. I would prefer to use the lower value and estimate our performance is gonna be worse. Okay, so now we need to find our actual rate of climb. What's the average here? And then we'll get our time.
Between top of climb and takeoff.
And top of climb. So what we're gonna do is we're gonna say our takeoff is 736 feet per minute. Our top of climb, we're gonna be doing 320 feet per minute. Sorry if that's hard to read. 320, that's 1,056. I know this seems just dead stupid simple. If we divide it by 2, our average climb rate is gonna be 528 feet per minute. Again, do your own thing, second guess me here, however. Just, this is how I do it, and it seems to work, so.
Instead of
doing all this extra math, just don't worry about it. The point is, 528 seems like a pretty reasonable average. And what that means is, if here's our starting, does this work? There we go, for now. If our starting point is here, and we are climbing to here, and this is TOC, top of climb, fix, this is Long Beach, about here, in the middle, we will be doing 528 feet per minute. So I'm happy to average and say from takeoff to what, 3750 or 2750, whatever, we will be doing 528. And from 2750 to 5,500 feet, we're gonna be doing 528 down to 320, right? So you can add more, you can add less. The point is, I'm just showing that I have the math on my side, so I can show this to you. You can read it and go, okay, cool, come in. You can read it and go, okay, cool, great, and move on with your life. And then if you go, well, how'd you get that? You can do the math. That's all that we're trying to prove here. And this is just for flight planning. So now that we have our average foot per minute, and instrument people, you'll understand now, for ODPs and stuff, at this point, we do our ODP, we get our ground speed, we divide our ground speed by 60 and multiply it times the foot per nautical mile required for the ODP. You now get your foot per minute required. Now you do this math and say the foot per minute required for the ODP is 700. We're saying at best we can do 528 through the middle of the climb, and at the top of climb we need to do 320. Well, for instrument, as you would know, we have to do that to that point. We have to do 700 the whole way. We can no longer do that ODP. So now you have to go to your other stuff, but focusing. We now have a foot per minute. What's important about this? Why does this matter? Now we know time. How? Well, are we climbing to 5,500 or are we climbing to 7,000? What's it gonna be like, right? What's the difference? Do we go off DA or indicated altitude when we're trying to find time? Like, if I divide the altitude change by the feet per minute.
You're gonna do by indicated.
Sure, yeah. So we'll say 5,500 minus 60, 5440. And if I divide that by feet per minute, time, 528, we now have 10.3 minutes. Cool. So we say 10.3 TOC. It's getting a little congested. Let me erase some of this. So I'll just get rid of that. So 10.3 minutes to top of climb. Well, how much fuel are we gonna burn to that top of climb? To the POH. When we go back to the POH, I know the number, but it's how can I prove it to you? How can I prove that what I'm doing is legal and accurate? I go back to my POH, we go to 5.5 for fuel consumption. What do we see? This is indicated at 3,000, so it's not even helpful, right? Are we at 3,000 this whole time? No. But what I need to know is my fuel burn and my RPMs. This is the only thing I have that's going to tell me the legal thing. So therefore, I'm going to ignore 3,000. I'm going to come over here. If I'm at max power in my climb, I'm gonna be doing 5,500 RPM, give or take, right? Whether it says it or not, I know that's what I'm pushing the engine towards.
Plus, you're going with the more conservative value.
Right, so I'm gonna go to the highest fuel burn because I'm climbing. You could even go higher. You could say 6 gallons per hour. I'm just, for this, we're gonna stick with the POH. It's 5.6. So we have 10.3 minutes, and we're burning 5.6 gallons per hour. Now, I'm a special guy, so it was hard for me to understand this. But if you take 5.6 and divide it by 60, that would be minutes.
You have gallons per minute.
So now we get gallons per minute, which is 0.093. And if we multiply that by 10 minutes times 10.3 minutes, we now have 0.96 gallons burned to top of climb. So we can come down here and say 0.96 gallon decrease, right? However you want to do this. Just make it simple. So we're going to burn 0.96 gallons. It'll take us 10.3 minutes, and we'll average a 528 foot per minute climb rate to top of climb. Again, now we can get our distance. How do we know how far we're going to go on here? Well, we know our ground speed, and we know our duration. It's all coming together. What did we say for our climbing ground speed? Was like 60 something? 68?
68.
So 68 is our ground speed. Our duration is 10.3 minutes. Make sure we have minutes right, our right values here. And now we get 11.67 nautical miles. So now we know that this distance is 11.67 nautical miles. I'm sure this looks impossible to read, but right, we just input that value. And so now what do we have? We have our foot per minute climb rate, our time, our fuel burn, and our distance. So now, when we go to our flight plan and our VFR navlog, right? How do we know where to put top of climb on here? How do I know where to say that, or top of descent? Well, now I know if the distance between Long Beach and the LA River is less than 11.7 nautical miles, then LA River stays. If Queen Mary is less than 11.7 nautical miles, it stays. But Huntington Pier, that's more than 11 nautical miles, so then top of climb will go here, Huntington Pier will go here, and now I need to change this value to where it reads 11.7 to top of climb. And see, now my math is accurate, and I can prove that because then they go, well, how? And these numbers will match up, and my time will match up. Obviously, this is estimated, it's pre-flight, but I can show how much work I put into this to prove that my math is accurate. And then if they ask me to do it in the plane, that's ridiculous, but you can. So, great. We have our climb performance done, right? We went indicated, calibrated, we went true, we got our ground speed. Once we got ground speed for the 2 places we wanted to go, from takeoff to our top of climb, we now have our cheat sheet. We know, on average, our climb rate, our time rate, our gallons, and our distance. So we are now just going to do the same thing for the remainder of our flight.
Just to clarify, so we, for our rate of climb, we got weather and wind.
Okay.
Or sorry.
I'll explain. So for our rate of climb, because this is important and it's complicated, we're gonna just one more time and then this video is done, because I'm sure it's like 50 minutes long at this point.
40 minutes.
Jesus. So, one more time, and then I gotta stop this because this is incoherent rambling. What we want to know is our ground speed and our true airspeed, right? Because if we have both of those, we know how fast we're moving, and to get true airspeed, we've got pressure, altitude, our temp, and our winds. Do you see how I'm thinking about this, right? Because what do we need to know our ground speed? We need everything we need to know to figure out where we're going and what we're doing. So it's our indicated altitude.
Yeah, I think the ground speed part is good.
It's our indicated altitude at TOC,
rate of climb.
and it's our starting point. We want to know what the difference in altitude between these is, because how much do we have to travel? So in our case, 5,500 minus 60 was 5,440. So we're moving 5,440 feet at 528 feet per minute. So if we divide that, because it's minutes, we will get minutes out of it, right? So we take a distance divided by time, right? Giving us more time. or rate, sorry. Distance divided by rate has now given us time. If we go all the way back to our triangle, right? Distance, so our top of climb to start, divided by our rate, 528 per minute rate, gives us time 10.3. And then we can do the same thing for the remainder of the flight. So you get your leg distance. Cool, our next waypoint is gonna be 8 miles from top of climb. It might have been 20 miles from the previous waypoint, but top of climb puts it a little further. So now you can find the distance from there, and then so on. And then your ground speed, again, because you have your true, you just keep getting true, and then with true and wind, wherever you are, you get your ground speed, so you can average that out. And then we just do the same math. If I'm doing 85 knots ground speed along my cruise portion, and I'm going to be cruising for 10 minutes to travel 9 miles, that's all I needed now. And you can do it waypoint to waypoint, or you can do your total and just average the numbers out. However, anyway, cool, thanks.
Cool. Yeah, so to get the rate, we needed weather and our POH.